Chapter 2, Section 1. This is Units of Area and Volume, Apprentice. So in this video I'm just going to talk about area and volume. It should be review. The definition of area, it's just the sum, meaning the total when you add them together. It's the sum of unit squares inside a two-dimensional object. So here I have a rectangle. It's 4 centimeters by 5 centimeters. So the units, of course, are centimeters. If I break it up into unit squares, that means each of these little squares here, okay, this is 1 centimeter, this is 1 centimeter. So the area is just the total number of blue squares that would fit inside this large rectangle. So one way, of course, is just to count them one by one, but a more efficient way would be to say, well, I have 4 here, and then I have 5 of those, so I have 5 groups of 4, or you could say 4 groups of 5, which is, by definition, multiplication. So that is why, to find the area of a rectangle, you just get to multiply the length and the width, or the base and the height, whatever you call it. So 4 times 5, of course, is 20, but our units are also being multiplied. So centimeter times centimeter, we get centimeters squared. Okay? So whenever you have a measurement that is conveying an area, whatever the units are, we need to have this little 2 here. All right, so let's just review a couple of basic shapes. If you have a square, of course, it's length times width, but when it's a square, the length and the width are the same. So we actually don't need to call them different variables. So I'm just going to say L squared, because that means L times L. Just some generic rectangle, that would be length times width, and you can just write it as LW. We're assuming we multiply. A triangle, okay, that is 1/2 times the base times the height. Okay? And sometimes this height is referred to as the altitude of the triangle. So I've seen formulas where this H is a letter A. It really doesn't matter what letters you choose, as long as you know what they represent. Circle. Well, when we're talking about circles, typically they involve the number pi, and that's times the radius squared. Okay? So remember, pi, it is approximately 3.14. Okay, but it does go on, and this is the radius. And remember, the radius is half of the diameter. Okay, so it's the distance from the center of the circle to the outside edge. So those are some basic formulas. All right, let's do a quick review of volume. The volume, it's the sum of unit cubes. So instead of little squares, we have little cubes. Oops, that's better. But we're talking about a three-dimensional object. So for example, I actually have the same rectangle as I did before, but I extended it into 3 dimensions. So this is 4 centimeters by 3 by 5 centimeters. And just like what we did with area, we're going to break it up into little squares, but of course now it's 3D. We have little cubes. So this little cube here, okay, I guess it would be hidden behind here. Okay, this is 1 by 1 by 1. So that is a unit cube, because we're in centimeters. And we just count, well, how many of these cubes are in this prism? So we have 4, but then we have 3 groups of 4. So this bottom layer, there would be 12 of them. But we have 1, 2, 3, 4, 5 layers of 12 cubes. So it's just multiplication again. So the volume is 4 centimeters times 3 centimeters times 5 centimeters. Of course, the order doesn't matter. 4 times 3 is 12, times 5 is 60. But our units are also being multiplied. So a centimeter times a centimeter times a centimeter. This gives us centimeters to the power of 3, or as we say, centimeters cubed. Let's look at a couple of formulas that you should be familiar with. So we have a cube. This is just like the shape up here, only all of these dimensions here are the same. So you can all call them all length. So I'm going to say L cubed. This means L times L times L. Rectangular prism, that's what we have up here. This is just length times the width times the height. Now, a triangular prism. Now you may see different variables used. Okay, let's see. I'm going to label this. I'll call this I'll call it the height. It's lying on its side. And I don't want to call this the height. You might call it the height if it was standing up. So just have to be careful. I'm going to call this the length. Maybe it's a tent or something like that. And this down here, okay, I'm going to call that the base. Okay, so the volume, well, we just find the area of this triangular face, which is just 1/2 times the base times the height. But we're just stretching, we're just extending it into 3D. So we just get to multiply it by L. So that would give us the volume of this triangular prism.